take a look at topic 6.1, key features of exponential functions. And here is your exponential function. You're going to have some a value. Whatever this a value is will be your y-intercept. You have b is your common ratio, and it is raised to, notice you have a variable in the position of the exponent. Now, a cannot equal 0 because, of course, if we're multiplying anything by 0, we just get 0. B has to be greater than 0, and b cannot equal 1 because, again, if we have a base of 1 raised to any exponent, it's just 1. So b is restricted there. Let's take a look at the graph of f of x equals 2 raised to the power of x. And just like we've done before, we're going to do a table of values, and we'll choose some values of x and we'll substitute it into our function. So here, if x is -2, we have 2 raised to the -2nd power. Now, if you have a negative exponent, remember, all this is going to do, it's going to go positive, and we're going to put this, what would be in the numerator, into the denominator. So this is 1 over 2 squared, which is 1/4. I have an x value of -1, so that is 2 to the -1st power. Well, that's the same as 1/2. 1 over 2 raised to the 1st power. 2 to the 1st power is just 2. Now I have 2 to the 0 power. Any number raised to the 0 power is 1. I have 2 to the 1st. 2 to the 1st is 2. And now 2 squared. 2 squared is 4. So now let's go ahead and plot our points and see what we get. So at -2, I'll say these are scaled by 1. At -2, I'm at 1/4, so I'm just a little bit over quarter of the way up. At -1, I'm at 1/2. At 0, I'm at 1. At 1, I'm at 2. And at 2, I'm at 4. 1, 2, 3, 4. Here we go. Now, this graph, if you can imagine, anytime we're negative, we've got negative x values. Notice that we ended up putting our base went into the denominator. So if you can imagine, as your x values are decreasing, here at -1, we had a 2 in the denominator. At -2, we had a 4 in the denominator. Your denominators, as you go down, are going to get bigger. The bigger your denominator, we've got a 1 in the numerator, the smaller your number is going to be. And understand, too, that there is no way I could ever have anything in the denominator that's going to make this equal 0. So my graph here is never going to touch the x-axis. I'll never have a y value of 0. I will never have any y values that are negative. What's going on here is this x-axis, y equals 0, is an asymptote. And this will just continually to go up exponentially. So there's our graph. So let's take a look at some of these key features. Domain. Your domain is going to be all real numbers. I can put any real number in for x, and my answer, my y value, will also be a real number. Now your range, as we just kind of discussed, my y values are never going to go below 0. They'll never equal 0. They will never go below 0. So my range is the set of all y such that y is greater than 0. My y-intercept, as we noticed here, remember when you're looking for a y-intercept, your value of your x is 0, and we came up with 1. We also saw that here in our standard form. Notice here, my exponent is attached to the b value. So my b value is 2. I don't see the a value, but we've had some experience with this before as well. If you don't see a number, it means it's 1. multiplication by 1 doesn't do anything. We don't always need to write it. It's kind of understood. So my A value is 1, and the B value here was 2. So that means my y-intercept is 0, 1. And you can determine that just by looking at your function if you understand that your A value is your y-intercept. We discussed we had an asymptote. It is at y equals 0. That is also the x-axis. So now your end behavior. As x approaches infinity, so my x values are getting bigger, where are my y values going? Well, my y values are going up to positive infinity. As I go the other direction, as x approaches negative infinity, my x values are getting smaller. Where are my y values approaching? Well, they're approaching 0. Remember, those values are going to get tiny, 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 tiny numbers. As my denominator gets bigger, my value gets smaller, but it will never equal 0. So I am approaching 0. Now, recall too, if you read a graph left to right, it's either going to be increasing or decreasing, or sometimes constant. Here, my graph is increasing. So it's good to note that if your B value is greater than 1, this is going to be increasing. Now let's take a look at another graph. Now here we have 5 times 1/2 raised to the x power. Right off the bat, I can see that my A value is 5. My B value is 1/2. So again, I should be able to see right away. I'm going to have a y-intercept at 5. Let's go ahead and do a table of values and take a look. So I'm going to have x is -2. So that means I have 5 times 1/2 raised to the -2 power. That is the same as 5. 1 to the -2 power, it's going to go in the denominator, but 1 squared is just 1. So we can write this as, I'll go ahead, I'll break it down, I'll flip it. So this is going to be 2 squared over 1 squared, which is going to be the same as 5 times 4, which is 20. This goes back down to your properties of exponents. Let's do x is -1. 5 times 1/2 raised to the -1 power. That is the same as 5 times, I'm going to flip my fraction. That's going to be 2 over 1. Everything is just raised to the first power. Don't need it. So that's the same as 5 times 2 equals 10. Now here's 0. This is going to be my y-intercept. So let's take a look. 5 times 1/2 raised to the 0 power. Well, again, any number raised to the 0 power is 1. And we get 5. So again, there it's manifesting itself as well. Right there in your A value. That is your y-intercept. And now 1, we have 5 times 1/2 raised to the first power. That is the same as 5 times 1/2, which is 5/2, which is the same as 2.5. We'll leave that as a decimal. And now 2. 5 raised to the 1/2 squared. 5, 1/2 squared is 1/4. So it's 5/4, which is 1.25. So now let's graph this. So at -2, I'm at 20. I'm way off there. At -1, I'm at 10. You know what we'll do? We'll scale this by 2s. We'll say each of these squares is 2. So at -1, that would be halfway here. 2, 2, 4, 6, 8, 10. -1, 10. At 0, we're at 5, 2, 4, here's 5. At 1, we're at 2.5, 1, 2, but halfway there. And then at 2, I'm at 1.5. So this is 2, 1.5, that's going to be right about here. And now as my exponent increases, my x values, and again, that's going to affect your denominator. Your denominator is going to get bigger and bigger and bigger, which makes your number smaller and smaller and smaller. So this is going to come down. It again is never going to equal 0. It will never become negative. So it's just going to skate right along the x-axis. Now let's take a look at some of our key features. My domain is still all real numbers. I can put any real number in for x and I'm going to get another real number out. My range, well, my range is still has to be greater than 0. The set of all y such that y is greater than 0. And my y-intercept. My y-intercept, we calculated here algebraically, is at 0, 5, and you can also see it in your a value, 0, 5. Your asymptote, we still have an asymptote at y equals 0. And behavior. So now as x approaches positive infinity, so my x values are getting bigger, where are my y values going? Well, now my y values are decreasing and they are approaching 0. As my x values are approaching negative infinity, so my x values are getting smaller and smaller and smaller, what's happening to my y values? They're getting bigger and bigger and bigger. So they are approaching positive infinity. Now, again, take a look at this. If we read this left to right, you can see your graph, your function is decreasing. So here we can say, if b is between 0 and 1, your graph is decreasing.